Circle the correct answer, no partial credit. In number 8, we are given that cosine theta is 2/3, 2/3. Then find the exact value of this. So we got 1, 2, 3 terms, and it's given cosine theta is 2/3 plus cosine theta plus 2 pi. As we know, sine and cosine have a period of 2 pi. So when we add 2 pi, which is 360 degrees, to any angle, we are back into the same place, so same value. So cosine theta plus 2 pi is same as cosine theta, and cosine theta is 2/3. So this is 2/3. Theta plus 4 pi, that's double of 2 pi, again going around twice, back to the same place, cosine theta. So 2/3. 2/3 plus 2/3 plus 2/3, 6/3, which is 2. So part C. Number 9, the amplitude of y equals 3 cosine 2x is, whenever we have sine or cosine, the number outside, that when we take the absolute value of that number, we get the amplitude. So this is already positive, so absolute value of 3 is also 3. So this is the amplitude. And the period, when we have a function y equals, let's say, a number a, sine or cosine, in this case cosine something x, so we write omega x, then period t is given by 2 pi over omega. So in our question, a like 3, cosine 2x, so 2 is omega, so the period will be then 2 pi over omega. Omega is 2, and 2 pi over 2 is just pi, so the answer is pi. The quadrant in which the angle theta lies, if cotangent is positive and cosine is negative. So 1, 2, 3, 4. So let's see. We know the rule, all students take calculus, so all trig functions are positive, sine and cosecant are positive, tangent and cotangent positive, cosine and secant positive. So we have cotangent positive, so that's gonna be either the first quadrant where all positive, or tangent cotangent here. So the answer is either first quadrant or third quadrant. At the same time, it says cosine is negative, so it's all positive, so first quadrant is not going to be the case, so cosine is negative in the third, so the answer is third quadrant. Okay. 12, the range of y equals tangent x is this, one of these. So if you graph y equals tangent x, then you will see a lot of vertical asymptotes, and one of the graph is like this. So it goes all the way from negative infinity through all the up to positive infinity. By the way, the range is all real numbers, negative infinity through positive infinity. So here is the case. Final.